solutions to the trigonometric equations. In many instances, when you're solving trigonometric equations, because the trigonometric functions are periodic, you get infinitely many solutions. Are there trigonometric equations that don't give you infinite solution? Yes, they are. But the ones that we discuss in pre-calculus, they all give you infinite solutions. So the difference between identity is that the trig identity is satisfied for all values or for all values given. When you're solving equations, you actually find the values that the equation is true. So you're solving for theta value that this equation is true. So let's start solving for one of them. The first one is telling you solve for sine squared 3 theta equal to 1/2. To solve for theta, first thing that I want to do is to solve for one of the trig values of theta, and that is, in this case, is sine. So I'm solving for sine 3 theta, and my options are plus and minus square root of 1 over 2, which is square root of 2 over 2. So either I get sine 3 theta equal to square root of 2 over 2, or I get sine 3 theta equal to negative square root of 2 over 2. Now, what angles their sine value is square root of 2 over 2. That could be either in the first quadrant, so I have two options. First quadrant, and sine is also positive in the second quadrant. So I get those two answers, and so I write 3 theta. I write 3 theta equal to pi fourth plus 2k pi, or the same value, 3 pi fourth plus 2k pi. Your last step should be basically solving for theta, that is dividing every term by 3. So pi over 12 plus 2k pi over 3, and theta equal to pi over 4 plus 2k pi over 3. And that was just the first solution to sine. The second solution to sine is a negative value. So it's either in the third quadrant or the fourth quadrant. And so for in the third quadrant, I know it's going to be 5 pi over 4 plus 2k pi. In the fourth quadrant is 7 pi over 4 plus 2k pi. And that gives me theta is equal to divide by 3 every term. And here theta equal to 7 pi over 12 plus 2k pi over 3. So these are all the solutions possible for any k in z equation. In this case, I can see that the only trig function in there is secant of alpha. So I should solve for secant of alpha. And that may require a u substitution, because I see secant of alpha and secant to power 2 of alpha. That reminds me of quadratic equation. And so doing that, I get u squared is equal to secant squared alpha. Therefore, this is going to be u squared, this is going to be u, and I get u squared minus 3u plus 2 equal to 0. Then I have to solve for u, and so u minus 2 times u minus 1 equal to 0 is the answer, and I get u equal to 1 and u equal to 2. Now, u is not good enough for me. I need to replace u by, and remember, u is equal to secant of theta. So eliminating u between these two gives me secant theta equal to 1 or secant theta equal to 2. Now coming back over here, if secant of theta is equal to 1, that means that I'm more comfortable with the cosine and sine identity, so I replace it by 1 over cosine theta equal to 1. That is cosine theta is equal to 1. The only time that cosine theta is equal to 1 is theta in one period is theta equal to 0 and plus 2k pi. So theta equal to 2k pi is one of the answers. Then I also have to solve secant of theta equal to 2. That is 1 over cosine theta is equal to 2. That is cosine theta is equal to 1/2. Therefore, the places that cosine, there are two places. Let's remind ourselves. One of them is in the first quadrant. The other one is in the fourth quadrant. So in the first quadrant, cosine of theta is equal to 1/2 at pi third. And in the fourth quadrant, pi third, it's 2 pi third, 3 pi third, 4 pi third. So if you look at your unit circle, you see that the 5 pi third is the answer. And this is the solution to that one. Now the last one of these is very useful also in different parts of mathematics, but I can see there are two different trig functions, and I'm solving for t, so I need to find one trig function, solve for one trig function, and this is causing me some problems. One way to resolve this problem is actually to divide both sides by cosine theta, cosine 70. And so I get tan of 7t is equal to -1. Therefore, tan is negative at in the second and fourth quadrant, but I only need one of them because the period of tan is only pi. So second quadrant. And then I go 7t is equal to in second quadrant is 3 pi fourth plus k pi for the, and then solve for t because that's the final goal. And this is the answer that you get in here.